Hello, hello. How's it going, everyone? Hey, Jazzy. How are you doing? Hope things are well. I believe the mic is working. Yes, it's working. How's everyone doing? Second week of the stay-at-home order. Everyone's probably getting cabin fever. I've done like 5 or 6 things to try and reduce the stream delay, and none of it's working. Let me adjust my mic a little bit. There we go. I don't know if any of it's actually working. I don't think so. I still think there's a 30-second delay, which is... whatever. It's what it is. But, yeah. It's kind of chilling. Just a quick update, and I'm going to announce it in Discord here soon. But tomorrow, yeah, the cabin fever is real. Tomorrow, there's not going to be a live stream, so you get a day off, per se. Basically, and I'll just readjust the work to move it one more day. Long story short, I have to go to San Dimas and pick up some stuff, and the small window in which I have to be able to go down there and grab some stuff happens to basically be overlapping this exact time. So it is what it is. I have grades that I have to turn in and stuff like that, and there's a few things over there, some tests and all that different stuff that I need so I can turn in those grades, submit all that different stuff, and I gotta go and I have to go and get it. So yeah, it's no stream. I get to be a bum and sleep in late. Don't be a bum. Don't be a bum. Don't die. Well, I mean, social distancing, right? As long as I'm 6 feet away from other people, everything should be fine. It's not like the virus spontaneously generates in the air. That would be scary if it did, though. If the virus was just appearing out of nowhere and just generating like right there, that would be really scary if that's what the virus did. But yeah, so just a heads up. I know you guys are going to miss me, but you guys can wait one day. Okay, so let's talk about the 70-2. Let's go over that lesson. So let me just pop this over here. So let's kind of take a look at that. So yesterday's lesson, we talked about 2 descriptive features on a rational function. We talked about the vertical asymptotes and then the points of discontinuities, aka holes. Yeah, 5 minutes, see? Whenever there's a long video, there's going to be a short video that follows up. No worries. But what we got to do is, in this video, we got to know how to find horizontal or oblique asymptotes. And so that's going to be the second element to our rational functions. Now, a horizontal asymptote, I said in this picture here, in this image, if you notice how the graph is actually, it seems like it's approaching this value here. Well, that value that it's approaching is my horizontal asymptote. And there's an actual way for us to be able to find where that leveling off is. And so for us to be able to do it, we have to memorize these 3 different scenarios here. And the 3 scenarios are where the degree of the denominator is larger than the top, where they're the same, and where the degree of the top is larger than the bottom. So those are the 3 scenarios that we have to memorize. Now, if the degree on the denominator is larger, it's automatically 0. Automatically. No matter what it says, no matter what the numbers are, it could be the longest polynomial on the denominator. If the degree on the denominator is larger, then it's automatically 0. So in this example here, if you notice, 3 is larger than this 2. So the degree on the denominator was larger than the top. And so therefore, automatically, my horizontal asymptote y is 0. Then, if the degrees are the same, meaning the degree on the top and the bottom are the same, so like in the example number 3, a 2 and a 2, so the degrees are the same, what you do is you take those leading terms and you divide them. So if I did 2x squared over x squared and I divided it, I'm left with 2. And what I'm left with, that's going to be my horizontal asymptote. So y equals 2. Now the big question is, why is it 2? Why is it when you divide them you get that? That answer comes more obvious when you get into calculus and you study something called limits. And the idea is you take numbers to infinity, and basically this number gets equally as big as this number. So that means if they cancel out, all the thing is left is that you get 2, because this is just going to go to infinity twice as fast. And so if we were having infinity over infinity, the infinities would reduce, and then you're just left with the 2. But mine is a very vague explanation. We don't need to worry about that. Calculus. Much more time to explain that part. And then the last is going to be when the degree on the top is larger than the bottom. There is no horizontal asymptote. We call it an oblique asymptote or a slant asymptote. And the way we find that is you actually divide the polynomials. But we're going to hit pause on that, and we're going to fast forward on how we find that in the future. All right, so there is the review on the horizontal asymptotes. Is there any questions on the definition itself before we go into and start working on the DI? How many viewers do I have? 6. So many lazy advanced math students. Sleeping in, staying up till 3 a.m. Man. It's like I physically can't do that anymore. It's weird. I remember being young and being able to just stay up till 2 days straight even if I wanted to. Now, 11, 12, 1 o'clock, I get this like headache, and it says, go to bed right now or you're going to die. So I go to bed because I don't want to die. All right, so seems like we don't have any questions, so I'll move that over. All right, so in this first example here, find the horizontal asymptote if it exists, find the slant asymptote if it exists. So finding the horizontal asymptote, I need to look at the degrees. So it's going to be that second case. You actually snoozed my alarm yesterday. That's okay. We missed you though. So x squared and x squared, so my degrees are the same. So all I need to do is divide the leading terms. So x squared over x squared, well that cancels out and I get 1. So my horizontal asymptote is going to be y equals 1. That's my horizontal asymptote. Now, there is only one or the other in terms of it being a horizontal asymptote or a slant asymptote. You will never have both. You're not going to have both a horizontal and a slant asymptote at the same time. It just won't happen. So it's like that's why we have to go through those 3 cases, because going through those 3 cases, it's going to allow us to determine for us which is which. Okay, so here we go. Let's go through these. So the first one, I have x over 3x minus 6. So my degree here is 1. My degree here is 1. They're the same. So that's the second case. So that means I have to divide the leading terms. And if I divide that, it's going to give me 1 over 3. So my horizontal asymptote is going to be 1 over 3. Comments or questions on that? I hate the delay. I wish I can talk to you guys live. I keep trying to figure things out. Endless YouTube searches on how to reduce delay, and it never, ever happens. Makes me sad. I increased the gain, so I think that made the quality better. I was noticing that it was picking up the air conditioning in the room. All right, next one. So number 2. So I have f of x equals x over x squared plus 1. So for this one here, the degree on the bottom is larger than the top. The bottom is 2, the top is 1, so my horizontal asymptote is automatically y equals 0. Boop-a-doop-a-doop. Questions with that one? On number 3, I deliberately set it up this way. I have x plus 7 over x plus 3 squared. Now, yeah, we look at this and we say x and x, oh, the degrees might be the same, but the fact that this is a square, I will get to number 4 very shortly. How do we divide if the denominator? Yep, polynomial long division. We're going to get there. So because that says square, what I need to do is I need to multiply this out first. So x plus 3 times x plus 3, and then multiply that. X squared plus 3x plus 3x plus 9. So then I get x plus 7 over x squared plus 6x plus 9. Now comparing them, well, the degree on the bottom is larger, so therefore my horizontal asymptote is y equals 0. Questions on that one? So just because looking at it, that square wasn't there, we need to make sure that you have to multiply it out first. Now number 4. Let me move that over. So x cubed plus 2x squared plus x over x squared minus x minus 2. So in this one, the degree on the top is larger than the bottom. So that means that it's supposed to be a slant or an oblique asymptote. Now, for us to find it, you just divide the polynomial. So I'm going to do x cubed plus 2x squared plus x divided by x squared. I needed to switch those. Whoopsie. So it's going to be x squared minus x minus 2, x cubed plus 2x squared plus x. And then placeholder. Can't forget the placeholders. So now all you got to do is just divide it. So x squared goes into x cubed, x times, multiply through. So x cubed minus x squared minus 2x, subtract. 0, 3x squared, and then 3x. Now we're going to divide again. So x squared goes into 3x squared 3 times. Now, I don't need to know anything else. I know because you can't get smaller than a number anything else that I do from there is going to be a remainder. This right here is what I need. So my asymptote is going to be the equation y equals x plus 3. This is the value that's important. The remainder, when we go, like I said, remember we're doing this whole going to infinity thing? The remainder becomes irrelevant because of that. Because as we go to infinity, it's x plus 3 that's going to be left over. Now let's look at that on Desmos. Watch what happens. So on top, I have x to the third plus 2x squared plus x. And then x squared, whoops, minus x minus 2. So this rational function has this weird shape. Now watch what happens when I do y equals x plus 3. As you see, and I'll make this, how do I make this dotted? There we go. So as you can see, the graph likes to approach this line here. And so that right there, because it's, instead of it being horizontal, we call that a slant asymptote. When it does different shapes, and the asymptotes can do different shapes, things can get really goofy, we call those oblique asymptotes. So that's the difference between the two in terms of the naming. Now, finding that slant asymptote, we are going to actually spend a day on graphing these. And when we spend that day on graphing these, we're going to focus more on the dividing and finding the slant asymptotes here. So if it makes you a little uncomfortable now, that's okay. We're going to have time, so no worries there. But just know that when the degree on top is larger, slant asymptote, you have to divide the polynomials. Before I move out from that, any questions on that one? So just to emphasize a little bit again, the reason why I stopped here is because anything else I do is irrelevant. The remainder is irrelevant. You don't have to worry about the remainder. It's infinitely small. A number is infinitely small compared to infinity. And when you get into calculus, it makes more. Okay. So no feedback there. So let's look at number 5. So I have x to the third over 1 minus x. So then this is going to turn into negative x plus 1, x to the third. Now, the reason why I did that is because the degrees. It's larger on top. I'm going to have to divide. So this is going to be negative 1 plus, or negative x plus 1. And then I get x cubed plus 0x squared plus 0x plus 1. And so now divide these. So you get negative x squared. Multiply. So you're going to get x cubed and then minus x squared. Subtract. Bring them down. Bring them down. Now this continues to divide in here, so I'm going to keep going. It's not going to be a remainder anymore. So x goes into, or negative x goes into x squared minus x times. Multiply. Negative x times 1 gives me negative x. Subtract. Bring it down. And then negative x goes into x. Oh, it's plus 0. You're right. I see it. It's plus 0. I don't know why I put the 1. I was looking at that. That's why I put the plus 1. It's plus 0. So negative x goes into x, negative 1 times. That value wouldn't have mattered anyways because it would have just turned into a remainder. Now, I'm going to stop here because anything else that I do is going to yield me a remainder. I don't need to worry about it. So my asymptote is going to be y equals negative x squared minus x minus 1. Now, because this is not going to be like a line, it's actually going to be an oblique asymptote. Let's take a look at that on Desmos. There we go. All right, so x cubed. Thank you for the help there, Jazzy. Over x minus 1. Okay, so it's like, what the heck? And I agree with you. This is a massive what the heck is going on. But now if I enter in this asymptote, it's going to make a little more sense. Negative x squared minus x minus 1. Now look at that. Makes it a little better. Look at that. That's crazy because the graph is following along that asymptote. The graph is following along the asymptote there. It's crazy. But you see how the graph is following it along there? And the graph is following it along there. So that's what happens when the numerator is larger, the degree of the numerator is larger than the degree of the denominator. Questions on that one? Okay. All right, so number 6, we're putting together everything from the past few days and putting those together, the yesterday and today. I felt that coming. I was like, I'm going to cough here. All right, so first piece, we have x over x squared plus x minus 12. So first wants us to find the domain. So to find the domain, we have to look at the denominator and find the exclusions. So this is going to be x over x plus 4 and x minus 3. And so x can't equal negative 4 and positive 3. So x cannot equal those values. So my domain is going to be from negative infinity to negative 4, union from negative 4 to 3, union from 3 to infinity. Now, you can draw it on a number line to help you guys visualize it. Can't be that, but it's everything else. So that's my domain. Now, yesterday's lesson, we said that whatever that domain is, we can classify that as a vertical asymptote or a hole. So if there's any factors that cancel out top and bottom, those are going to be the points of discontinuity or a hole. And so in this instance, nothing cancels out. So because nothing cancels out in terms of any holes, I do not have any or none. My vertical asymptotes are then these values here. So my vertical asymptotes are x is negative 4 and x is 3. And then my horizontal asymptotes or slant asymptotes or whatever, kind of jumped the gun there. But the degree on top is 1, the degree on the bottom is 2, so it's automatically y equals 0. This right here, besides the end behavior, because rationals have end behavior, this is essentially all of the descriptive features of a rational function. I mean, we still have x-intercepts. We still have y-intercepts. Besides that, though, these are the descriptive features of a rational function, like the unique descriptive features. Holes, horizontal asymptotes, vertical asymptotes, slant asymptotes. So there's not really anything else that we're going to talk about in terms of newer descriptive features than that. We are talking about in behavior tomorrow, or Thursday, because I won't be here to do a stream tomorrow. Any questions on this one? Okay. All right, number 7. So it says find the x and y intercepts of the graph if any exist. So I have x squared plus y squared equals 4. So my x-intercept, I have to do y equals 0. So I plug in 0 for y. You get x squared plus 0 equals 4. X squared equals 4 square root. You get x equals plus or minus 2. So my x-intercepts are going to be 2, 0, and negative 2, 0. For my y-intercept, I have to do x equals 0. Now if I plug in 0 for x, the same thing happens for y. So then my y-intercepts are going to be 0, 2, and 0, negative 2. So that's going to be my value there. Any questions on that? Technically, these are the answers, even though I circled everything. Correct. Number 8. So it says write the set in interval notation. So it's the values of greater than 2 and then or x is plus or minus 1. It says also test symmetry. All right, I'll go back and test symmetry. I'm just kidding. Okay, so it's going to be negative 1 union 1 union 2 to infinity. Any questions on that one? It does say test for symmetry. Bum, bum, bum. Yeah, I didn't see it. I'm looking at like 3 things. Looking at my stream. Looking at, because like the volume and all the different stuff and the feed. Looking at the chat. Looking at the screen. And it's just an excuse. All right, so testing for symmetry. So x squared plus y squared equals 4. So symmetric about the x-axis. Okay, that means that if this is my x-axis, symmetry about it means that my y values are changing from positive to negative. So that means I need to plug in a negative for my y. Now, does that equal the original? The answer is yes. So symmetric about the y-axis. So if this is my y-axis, that means that it's the x values that are going positive to negative. So that means I plug in a negative for x. Does that equal the original? The answer is yes. And then symmetric about the origin just means both. So negative x squared plus negative y squared Does that equal 4? The answer is yes. So it is symmetric about the x-axis, the y-axis, and the origin. Questions on that one? Okay. Number 9. X squared plus 4x plus 7 is greater than or equal to 5x plus 9. So for this one, it's an inequality. So I know that I'm going to have to do a number line and I'm going to have to test true or false. I just need to find the values on it. So we're pretending that it's an equal sign. So minus 5x minus 9. So I'm going to get x squared minus x minus 2 is greater than or equal to 0. So then factoring, I'm going to get x minus 2 and then x plus 1. So that gives me x equals 2 and negative 1. So now I'm going to put those on the number line. Closed circle. And now I test true or false. I'm going to test it to this one with everything being brought over. Just makes it a little easier. So if I plug in negative 2, that gives me 4. Plug in negative 2, that's going to give me positive 2. So 4 plus 2 is 6. 6 minus 2 is 4. 4 is greater than or equal to 0. That's true. If I plug in 0, 0 minus 0 minus 2 is negative 2. Negative 2 greater than or equal to 0. That is false. And then plug it in 3. 9 plus 3. No, sorry. 9 minus 3. That's 6. 6 minus 2 is 4. That's going to be true. And so shade the values that are true. So my answer is going to be negative infinity to negative 1. Bracket, because it's closed circle. Union, and then bracket 2 to infinity. Look how that just fit perfect around the head, right? It didn't go in the space. It's like this right here. It's the box that blocks. All right, so that's the DI. Are there any questions with any of the values here? Any of the other questions? Cool. Well, if there are no questions, we are done. I will see you guys not tomorrow, but I will see you guys on Thursday. I'm going to update the online learning thing. That's the big slideshow. Also, I'm going to be updating that very soon for the coming weeks and what we're going to do. So next week's is going to be updated probably sometime tomorrow. So you guys will know what to do then for the upcoming weeks. Other than that, I think we're good, guys. Really appreciate you guys. Stay safe, be healthy, make good decisions. Don't stay up too late. Please get your schoolwork done. It's very important. Trust me, trust me, trust me. It's important. And moving on to the next class, I want everyone to be successful on whatever math class that they're moving on to next. So please, please, please do the best you can and continue working hard. Other than that, I'll see y'all later.